These are more worked out solutions for benchmark number 2, and this is at the bottom of page number 1. So questions 10 and 11, and that's what the Q stands for here. Just question 10 and number 11 ask us to solve absolute value equations or inequalities. So I would wager to bet that you're going to have one equation like this and one inequality like this. So let's take a look at them all. So here we have 4 minus, and then we have this absolute value. So what you want to do here first is you want to isolate absolute values. So I'm going to move this forward to the other side. I'm going to subtract it. Now when I do that, here's what I'm left with. I've got this minus sign that I bring down, and I've got the absolute value bars with x plus 2 inside. It's still greater than or equal to, now it's negative 12. Well, the next step is to isolate this further. You want to get rid of any number that's in front, and this is pretty much a negative 1. So what I'm going to do is I'm going to divide by negative 1 to cancel out those negative 1s. And a couple things happen that we need to remember. First of all, we've got an x plus 2 still inside absolute value bars. But now the inequality sign switches directions when we divide by a negative. And we got a positive 12 now. So now we're able to solve. So when we do that, here's how you're going to do it. Take this x plus 2 and set it less than or equal to 12, which it is, but set it greater than or equal to negative 12. Remember, if you divide by a negative, it switches, and so you see how it points to the x plus 2 for the positive 12, but it needs to be open for the negative. So we go ahead and do some opposite operations there. We subtract the 2, and we'll have our answer. So when we do that, we're left with a negative 14 is less than or equal to x, which is less than or equal to 10. That's our answer right there. So the key is make sure that you have the absolute value isolated, and with inequalities you're going to end up with those inequality signs. Now let's say they asked us to graph this. This ends up being a conjunction. So we got negative 14 off to the left, positive 10 over here. So the values of x are less than the 10, less than or equal to, so solid circle, and greater than or equal to 14. So they're all the numbers in between. Well, this one's already set up to solve. See, all we have to do on the equation, there's not as much work. You don't have to worry about the inequality signs. So we just got 2x plus 1 equals 13, and set it equal to negative 13. But you do have to isolate the absolute value. It was already isolated, so no more work to do there. So we're going to take away that 1 from all sides. And when we do that, here's what we get. We got a negative 14 equals 2x, which also equals 12. So we go ahead and do some work there. We're going to divide by 2, and we'll have our answers. So we go ahead and do that work. We've got a negative 7 equals x, which also equals 6. So there it is, our 2 answers. Just 2 in this case, negative 7 and 6. Well, again, this next one, we have to isolate the absolute value. Always get rid of any number that's in front of those absolute value bars. So in this case, we'll divide by that 3. And so rewrite what's left. You got an x plus 2 is greater than 4. So once you've got the absolute value isolated, forgot to put those bars around it. Once you have it isolated like it is, then we can set that x plus 2 greater than 4, but less than negative 4. And think about your answer. Okay, it's going to be greater than the positives. So over here are the positive numbers. We don't know what number yet, but the positive numbers are off on this side. Negatives are off on this side. So it's going to be greater than the positives. So that means it goes off in this direction. It's going to be less than the negative. That's what it says. See, x plus 2 is greater than the positive, less than the negative. So this is going to be a disjunction. That means it's going to be an or statement. So we're going to have to use the word or in between when we come up with our answer. So here I'm going to take away 2 from all sides. And when I do that, I'm left here with a negative 6 is greater than x, which is greater than 2. So this is you're not going to see this answer on the test. Now, be careful. It's going to be tricky. They're going to have the same numbers with x in the middle, but they're going to have the inequality signs go in the opposite direction. That would be wrong. See, the values of x have to be less than the negative, but greater than the bigger number, the positive in this case. So when you see the answer, it's going to go this way. X is greater than 2, or x is less than negative 6. So make sure your inequality signs match with the answer that they have there. Well, one more like that. Let's take a look at this one here. It's already isolated, so all we have to do is set that 2x minus 4 equal to the two numbers, 22 and negative 22. So go ahead and do some work there. You first need to add the 4 to all sides. And when we do that, remember opposite signs are going to end up subtracting. Same sign you're going to end up adding. So negative 18 equals 2x, which equals 26. So one more step there, just divide by 2 on all sides. And we've got our answer. So we end up with a negative 9 equals x, but x also equals 13. So there it is, negative 9 comma 13. Well, let's take a look at the next set of directions. And it says that there's lots of problems, 12 through 26. And they're to solve equations and inequalities. So they could be a number of different ways. Some of the problems will just ask you for the first couple steps. Some of them you'll end up having to solve all the way. So on these problems, they're just asking us to solve all the way, and that's what we'll do. So on this first one here, we've got a proportion. So if you don't remember from last year about proportions, you can cross multiply. That's one of the rules. You take that 3x minus 2 and cross multiply with this 3. So it becomes 3 times by 3x minus 2. Over on this side, same thing. 4 equals 2x plus 1. Multiply those numbers. 4 times by 2x plus 1. So we go ahead and do that work there, and here's what we get. We distribute, and so we end up with a 9x minus 6 equals 4 times 2x is 8x. And 4 times 1 is 4. And then from there, it's just opposite operations. So we're going to isolate the variable, subtract the 8x from all sides, and add the 6. And when we do that, we end up with x by itself, and in this case, it equals 10. There is our answer. Well, this next one has a couple more steps. You just got to be careful with the signs and make sure you distribute. So let's take a look at this. Common mistake people want to make is subtracting 2 from 4, but that's wrong. You've got to distribute first because multiplication, which is what this is, negative 2, is being multiplied by this sum, x plus 3. That needs to be done before any addition or subtraction. Same thing here. So what we have now is a 4, and it's a minus 2x minus 6. That's greater than or equal to, bring down the 3 and multiply. So we have 10 plus 20x. So from that point, all we're doing is combining some like terms. See where we have some like terms to combine. Over on this side, we just have the 3 and the 10. So we go ahead and do that work. Now we've got, still have that negative 2x I brought down. Here we subtracted these two because they're opposite in sign. That's why it's negative 2. Bring down the inequality. We have 13 plus 20x. So I just combine these two because they're the same sign. So now it's a matter of doing some opposite operations. So here we're going to, let's go ahead and add that 2x to both sides on this side. And then I'll go ahead and subtract that 13 from both sides on this side. So here they're the same sign, so I'm adding those two numbers together. Get negative 15. Greater than or equal to 22x. Well, in this problem, it's not going to work out as cleanly as the last one. I got to divide by 22, and I've got my answer. So let's talk about the answer real quick. I got a fraction, just negative 15 over 22. Bring down the inequality sign. Now, I don't switch that inequality sign because I divided by a positive, not a negative. Now, on the test, it's multiple choice. So they're going to have an answer, but it's not going to look like this. The reason is they're going to have x on the other side. So if you see your answer, you get your answer like this. Look at the answers they have and make sure the answer that you pick has the inequality sign facing the same direction. See how it points to the x here? It should point to the x if you move it to the other side. So whenever you move term to the other side, it ends up switching the inequality sign, but it'll still match. See, negative 15 over 22, it's open to that. Same thing over here. And so that's our answer. Well, another problem here, we have to use the distributive property first. So we're going to distribute that 3 over that difference. And over here, again, don't make that mistake of subtracting 2 from 5. Distribute that negative 2 over that subtraction first. So what we have now is a 3x minus 24. And this all equals, bring down that 5. We've got a minus 12 and then a positive 10x. So on the right-hand side, we can go ahead and collect some terms. See, we have this positive 5 here, this negative 12 here. Those will combine together to make one number. So we bring down that 3x minus 24. It all equals negative 7 plus 10x. So from that point, we just want to do some opposite operations. So I'm going to go ahead and subtract this 3x from all sides. Subtract the 3x. And over here, I'm going to add the 7. Add the 7. So when I do that, I've got opposite signs here. So I end up having to subtract, taking away 7 from 24. Leaves me with negative 17 equals, and then this makes a 7x positive. And so one more step there, divide by the 7, and you got your answer. So they can write it as an improper fraction as the answer, negative 17 sevenths. You might also see 7 going into 17, which goes in there 2 times with 3 left over. So negative 2 and 3 sevenths would be another way to write that answer. Well, one more problem to try. We've got some more signs to distribute, so numbers as well. So negative 3 over that subtraction. Over here, when you have the minus sign right in front of the parenthesis, remember we can put a negative 1 there, or just a 1. And it's negative 1 that we want to distribute over that subtraction. So what we should have is negative 3x plus 6. On this side, we bring down that 2. And we go ahead and do that work inside with that negative 1, makes a negative 2x plus 5. So from that point, we're ready to start combining some terms. Over here, we can combine the 2 and the 5. So when we do that, we're still left with this negative 3x plus 6, but now it equals, combine these two terms here, 2 and 5, end up giving me 7. And so don't subtract. Remember, look at the signs in front of the terms, not behind. So we go ahead and bring down that negative 2x and start doing some opposite operations. So I'll add this 2x to both sides here. And I'll go ahead and subtract this 6 from both sides. So when I do that, I have opposite signs. So I end up having to subtract these two. I get negative 1x equals, and then 7 minus 6 makes 1. So from that point, just one more step, get rid of that negative sign. That's why it's always real important to watch those signs. Don't make that little sign error there. Divide by negative 1, x equals negative 1 in this case. So there it is. Answers for the first page of this week's study guide. We'll continue on more parts of these solutions after this.